My name is Alec Goulet, and for week 7 here at Doane University with the General Chemistry 2 with Dr. Ken Capps, we're going to be looking at magnetic fluid. Unfortunately, due to some Amazon shipping delays, I was unable to get some of the materials, so I could not perform the experiment myself, but I hope that I can do it once the shipment finally comes in. I also looked at Office Max, Staples, Best Buy, and Walmart for the supplies, and I was unable to find the toner or the iron oxide materials to do this experiment, but I'm going to do my best to explain this and what happens with this experiment. So just a quick overview of the presentation. We'll be looking at the definition of the magnetic fluid. We'll be talking about that, how to conduct the experiment, including the materials needed and the process, what we would go through, and then we'll take a look at this in a video experiment. So, what is magnetic fluid? Well, magnetic fluid is actually referred to as ferrofluid. This is a liquid that attracts to the poles of a magnet and is a colloidal liquid made of nanoscale ferromagnetic or ferrimagnetic particles suspended in a carrier fluid. Each magnetic particle is thoroughly coated with a surfactant to inhibit clumping. The particles suspended in the ferrofluid conform to the Brownian motion, which means particle movement is generally random and the liquid will not settle under standard conditions. As we see here, this is a picture of a ferrofluid. Underneath is a magnet, and as we get closer to the magnet, something interesting happens. We see almost what looks like spikes that are created by the magnetic field. What happens in the fluid is the spikes are observed and arise from the tendency of the particles to line up along the magnetic field lines to lower their energy. The surface tension of the fluid, however, limits the extent to which the particles can align themselves with the field. So the elements of the experiment, we will need a printer toner or iron filings, iron oxide powder such as magnate, which is the Fe3O4, which is also known as printer toner, and hematite or Fe2O3 could be used. Also need some type of jar to put these in, something to stir them with, along with some vegetable oil, and a rare earth magnet. Interestingly enough, toner uses the magnetic properties basically to adhere to the surface of the printer, and then it gets transferred onto the paper. First, we will start by adding about 50 mL of the printer toner into a glass jar. Next, we will add about 2 tablespoons of a vegetable oil into the jar. We're going to stir these up nicely so everything is mixed in well. Next, once everything is fluid and together, we will transfer it into a different jar so we can manipulate it easier. As you can see, this is a pretty consistent liquid, but has some interesting properties when we add the magnet to it. As you watch here, it goes from a liquid, and then there are the spikes that are created through the magnetic field as everything lines up. As we move the magnet, the fluid moves with it, along with these spikes, as you can see. We can even invert this and have the fluid become inverted and suspended in the air through the magnets. Pretty cool stuff here. Additionally, we can even pour it onto a table with the magnet underneath, and furthermore even manipulate the magnet to write something with the ferrous fluid that we created.